Hello everyone, welcome back to our channel. In this video, we'll be solving these questions related to exponents. To solve these questions, you need to know some of the laws of exponents, which we will talk about as we solve these questions. So let's get started. So first, let's solve our first question, which is 64 to the power 1 by 2. Okay, so how do we solve this question 64 to the power 1 by 2? The first step that you need to do to solve these type of questions is first you prime factorize this number 64. So let's do that in our rough here. So we have our 64. By prime factorization, we mean we have to divide this number by the lowest prime number first. So the lowest prime number that can divide 64 is 2, right? So 2 3s are 6, 2 2s are 4, so we have 2 32s are 64. Again, let's continue our process. So we have 2 1s are 2, the carryover goes there, so we have 1 2 12, so 2 6 are 12. Again, we can divide this by 2, so we have 2 8s are 16, and then again if we divide it, we get 2 4s are 8, and then we have 2 2s are 4. So how many 2s do we have? So let's count. We have 1 2 3 4 5 6 2s. So 64 is equal to 6 2s, right? So 2 times 2 times 2 times 2 times 2 times 2. We can write this as 2 to the power 6 since there are 6 2s. Now the first step that we do is we just write this 64 as 2 to the power 6, which we found out by using the prime factorization, and we have our 1 by 2 over here. Now the next step involves a law of exponent. The law of exponent that we are going to use here is that if we have something like x to the power a and then we have power b over here outside the bracket, so if we have two powers very close to each other like this, what we do is we multiply those two powers. So what we'll get is x to the power a times b. So this is the law of exponent that we'll be using in our next step, and we will be using this law many times to solve most of our questions in this video. So if we were to use this law, what we are going to get over here is we have 2 to the power 6. These two powers are going to get multiplied, so we have 6 times 1 by 2 or 1 over 2. Now we can easily cut these, right? So we have 2 1s are 2, 2 3s are 6, and then we have 2 to the power 3 times 1 is 2 to the power 3, which is 2 times 2 times 2, which gives us 8. And that's it. Our first question is solved. So the first thing that we did is we did our prime factorization, and after that we use our law of indices or law of exponents, where you multiply two powers if they are close to each other or if they are separated by the bracket. So if we do those two things, we can easily find answers to most of our questions. Now let's see if we can find the answer of our second question like this. So our second question was 32 to the power 1 by 5. To solve this question as well, let's repeat the same process as we did for the first question. So the first step is prime factorizing this 32. So we have 32. We can divide this by 2. 2 times 16 is 32. 2 times 8 is 16. 2 times 4 is 8. And 2 times 2 is 4. So we have 5 2's over here, okay? So we have 5 2's. Now we can write this 32 as 2 to the power 5. And then we have a 1 over 5 over here. Now if two powers are separated by a bracket or if they are very close, we can multiply those two powers. So what we are going to get is 2 to the power 5 times 1 over 5. Again, we can cut this 5 and this 5, right? 5 times 1 is 5, 5 times 1 is 5. And what we're going to get at the end is 2 to the power 1 times 1 is 1. So you don't need to write this one, but let's write it for now. So 2 to the power 1 is 2, and done. That's our second question. So it's pretty simple, okay? We prime factorize it and then multiply the powers. Now let's see our third question. So our third question was 125 to the power 1 over 3. Okay, so we have our third question, which is 125 to the power 1 over 3. Now you can try to solve this question by yourself. You can pause the video and try it out, and then you can come back here and check whether your answer is correct or not. So if you have tried to do this question, the first step is again our prime factorization, right, which is 125 again. So the lowest prime number that can divide this 125 is not 2. We cannot divide it by 2. What about 3? We cannot divide it by 3 as well, but we can divide it by 5. Okay, so we have our lowest prime number that can divide this 125 is 5. 5 times 2 is 10, as the 2 goes to over here, right, the carryover, and we have 25. So 5 times 5 is 25. So we get 5 times 25 is 125. Again, we can divide this 25 by 5. So 5 5s are 25. So we are getting 3 5s for 125. So we can write this 125 as 5 to the power 3 or cube. And then we have our 1 over 3 over here. Now again, we are going to use our law of exponent. That is, we are going to multiply these two powers. So we are going to get 3 times 1 over 3. Now again, we can cut these two 3, and then we'll get our answer as 5 to the power 1, which is ultimately 5. And that's our third answer. Now these 3 questions were pretty easy. We just used some prime factorization and multiplied the powers. Now let's look at our second type of questions. So in our second type of question, we have this number 3, 2, and 3 over here, okay? In our first question, we only had 1, but here we have other numbers than 1. So we have 3, 2, and 3. Let's see what's different. Or maybe it's pretty similar, okay? Let's see. So let's try to solve the first question, which is 9 to the power 3 over 2. So we have our first question as 9 to the power 3 over 2. So the first step is again doing the prime factorization, right? So let's prime factorize 9. So we have 3 times 3 is 9. So 9 is simply 3 square. And we have 3 over 2 over here. Again, we multiply these powers. So we are going to get 3 to the power 2 times 3 over 2. Again, we can cut these numbers, right? 2 times 1 is 2, 2 times 1 is 2. And we have our 3 over here, and 1 times 3 is 3. 3 to the power 3 over 3 cubed is 27. So it's the same as the first type of questions. Let's try the second one. So our second one was 32 to the power 2 over 5. Again, we are going to repeat the same process for this question as well. So we have 32 to the power 2 over 5. If you remember, we already prime factorized 32 somewhere above. So we have 32 here. We factorized this, and then we got 5 2's. So I'm not going to repeat this whole process again. We know that 32 is 2 to the power 5, right? So I'm just going to write that. We have our 32 as 2 to the power 5, and we have our 2 over 5 over here. Now we can multiply the powers. So we have 2 to the power 5 times 2 over 5. Again, we can cut these two numbers, and then we'll get our answer as 2 to the power 2 or 2 square, which is 4. And done. That's our second question. Let's do our third question. Our third question was a 16 to the power 3 over 4. So we have our third question as a 16 to the power 3 by 4. If you factorize 16, we are going to get 2 to the power 4. So we are going to divide this by 2 first. 2 8s are 16, 2 4s are 8, and again 2 2s are 4. So 2 to the power 4, okay? Now let's write that over here. 16 is 2 to the power 4. Outside we have 3 over 4 equals to 2 to the power 4 times 3 by 4. Again, we can cut this of 4 and this 4, and then we are going to get our answer as 2 to the power 3 or 2 cubed, which is 8. And done. That's our third question. Let's look at our fourth question. our fourth question was 125 to the power minus 1 by 3. Okay, so this one is a little bit different because we have a negative in the power over here. We will talk about that negative power in a second. First, let's do the same thing that we have been doing till now. So first, let's prime factorize 125. And we have actually done this one before as well, but still, let's do it once more. So 525s are 125 and 55s are 25. So 125 is 5 to the power 3. And we have our minus 1 by 3 over here. Again, we multiply these two powers, so we have 5 to the power 3 times minus 1 by 3. Again, we can cut this 3 and this 3, right? And we are going to get our answer as a 5 to the power minus 1. Now over here, we are going to use another law of exponent, okay? And that law is, if you have something like x to the power minus a, we can change the symbol or the sign of the power or the exponent if we move this whole expression in the denominator, okay? So if we write it as 1 over x to the power a, then this is correct. So if you move this whole expression in the denominator, the power changes its sign. So the negative becomes positive over here. Similarly, if you add something like, let's say, 1 over x to the power minus b, if you move this whole expression to the numerator, again, the power or the exponent is going to change its symbol from negative to positive. So we can write this as x to the power plus b, okay? So this is another important rule of exponents, where we can change the sign of the expression, of the power of the expression, if you move the whole expression to the numerator or the denominator, okay? If you move it up and down, you can change the sign of the power. So here we have negative 1. If we move this entire expression in the denominator, we are going to have 1 by 5 to the power positive 1, okay? And this is just 5 to the power 1, right? So we can write it as 1 by 5 to the power 1 is 5, and that's it. So that's our answer of our fourth question. We can also directly write this as a 1 over 5, okay, because the negative 1 becomes positive 1 in the denominator. But you might get confused, like, where did the negative 1 disappeared, right? Just for that reason, I'm showing this process. The negative 1 is becoming positive 1 when it goes to the denominator, and this is ultimately 1 over 5, okay? And that's our fourth question. So in case of negative powers, you need to move things up and down to get them into positive powers. You can leave it as 5 to the power minus 1 as well, but it's usually taken not as proper, okay? If you can try to remove the negative things in your answer, and that would be a better answer. Usually people think like that, or maths people think like that, okay? And that's the reason we are getting our answer as 1 over 5. And that's our fourth question. Now let's look at our third type of questions. So our third type of question is actually simplify. We need to simplify these questions. It's also pretty easy, but you need to know how to add and subtract fractions, I guess. Let's look at the first question first. So we have 2 to the power 2 by 3 dot is multiplied 2 to the power 1 by 5. To simplify or to solve this question, you need to know another important law of exponent, and that law is, if you have a same base such as this, x to the power a dot x to the power b, and if they are in the form of multiplication, okay, so we have same base x and they are different powers. If you multiply these two where we have same bases, then what happens to the exponents or the powers is they get added. So we have x to the power a plus b. That's one of the rule of exponents. And another one important thing is, if you have something like x to the power a divided by x to the power b, okay? So instead of multiplication, if you have division, then what happens is the power gets subtracted, okay? So we have x to the power a, and then when this b comes to the upper part or upper side, we get minus b. So if there is multiplication, then we add the powers, and if there is division, then we subtract the powers. To do this, the important thing is the base needs to be same, okay? If the base is not same, then we cannot do it. The base needs to be same to add and subtract the powers. In our particular question, the base is same. We have 2 over here and 2 over here as well. So what we can do is, since it's in the product form, we can add the powers. What we are going to get when we add the powers is 2 to the power 2 over 3 plus 1 over 5. Now we have two fractions. Now what we need to do is we need to add these two fractions. Now do you know how to add these fractions? That's the main thing, okay? These are unlike fractions. We cannot add unlike fractions. So to add, we need to make these like fractions. Now how do we make these like fractions? We can make these like fractions, or we need to make the denominator same of both these fractions. We have 3 over here, we have 5 over here. To make the denominator common, we need to take the LCM of 3 and 5, or the lowest common multiple of 3 and 5. The lowest common multiple of 3 and 5 is 15. Now, how do I know that? There are lots of ways, right? So we can actually write the multiples of 3 and 5. The multiples of 3 is 3, 6, 9, 12, 15, 18, and dot 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 dot. And the multiples of 5 is 5, 10, 15, 20, dot 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 dot. So the lowest common multiple is 15. That's how I know that it is 15. Another way I know it's 15 is if you have two prime numbers, 3 and 5, then the LCM of two prime numbers is actually their product. This is 3 times 5 is 15. So we have the LCM as 15. Now what we need to do is we need to make both of these denominators 15 so that they change into like fractions and we can add them. Now how can we do that? We can do that by multiplying this 3 with 5, and we can't just multiply the denominator, we have to multiply the numerator as well with 5. Similarly here, to make this 5 15, I need to multiply this with 3, and again in the numerator, again I have to multiply with the same number, which is our 3. When we do this, what we're going to get is we have 2 times 5 is 10 over 3 times 5 is 15 plus, the plus was here in the power, I forgot. So we have 1 times 3 is 3 divided by 5 times 3 is again 15. Now we can add these two powers, okay, because they are like fractions. So we have 2 to the power 10 plus 3 divided by 15, which is going to give us 2 to the power 10 plus 3 is 13, and divided by we have our 15. And that's our answer. Okay, so the tough part is not the exponent itself, the rule of exponent. It's pretty easy, you add the powers. The tough part is just adding those two fractions. And if you know how to add fractions, it's pretty simple. You just add those two fractions and you get your answer. So this simplified question is a little bit tough because you need to know the basics like the LCM thing and adding fraction. If you know those basic things, it's pretty easy. So that's our first question. Now let's do our second question. Okay, so our second question was 1 over 3 to the power 3 whole bracket power 7. Again, this is a little bit different than our first question, and here again you need to know another law of exponent, and that particular law is not that difficult, but you do need to know that. So if you have something like x over y or x by y to the power a, then this is going to be equal to x to the power a by y to the power a. Okay, so the power goes to both the numerator and the denominator. Or you can look at it in this way. If you have something like x to the power a by y to the power a, this is going to be x by y whole power a. Okay, the opposite of this rule also holds. We're going to use the first one over here, but the opposite also holds, okay? In some cases, you might need to use this opposite scenario. So how do we solve this particular question? By using that rule of exponent. So we have 1 over 3 to the power 3 whole bracket, we have power 7. This 7 goes to both the numerator and the denominator. So we have 1 to the power 7 divided by, we have 3 to the power 3 already here, and this 7 also comes with the denominator. Okay, so the 7 is going both to the numerator and to the denominator. That's what we're doing here. We're just using the first rule. Now the second step is 1 to the power 7 is this plain 1, divided by, we have 3 to the power 3 and 7, and we just discussed this before. If you have two powers close to each other or separated by bracket, you multiply them. So we have 3 times 7, and our answer is 1 over 3 to the power 3 times 7 is 21, and done. That's it. It's not that difficult. Okay, you just need to know some of the rules of exponents. So that's our second question. Let's look at our third one. Okay, so our third one was 11 to the power 1 by 2 by 11 to the power 1 by 4. To solve this particular question, we already discussed about the law of exponent, which is when we have x to the power a over x to the power b, when we have division, we subtract the powers. So we have x to the power a minus b. Now let's do the same thing over here. Since we have the same base 11, so we have 11, and we have two powers 1 over 2 and 1 over 5. We're going to subtract them, so we get 1 over 2 minus 1 over 4. Again, to subtract these two fractions, again they are not like fractions, so we need to make the denominators common. To make the denominators common, we need to know the LCM of this 2 and 4. So the multiples of 2 is 2, 4, 6, dot, dot, dot. The multiples of 4 is 4, 8, dot, dot, dot. The lowest common multiple is 4, right? The LCM is 4. So we have to make both the denominators 4 so that they have common denominators. So let's do that for our first one. So we have 1 over 2. To make this 2 4, we just multiply it by 2. And you have to do the same thing in the numerator. So you multiply the numerator as well by 2. Minus, we have 1 over 4. So to make this 4, you don't need to make this 4. It's already 4, so you don't need to do anything. And then we have 11. When you multiply 1 and 2, you get 2 over 2 times 2 is 4. So our first fraction has 4 as the denominator. Minus, we have 1 over 4. Our second fraction also has 4 as denominator. So they are both common denominators now. Now we can subtract them. So we have 2 minus 1 over 4, which is going to be equal to 11 to the power 2 minus 1 is 1 over 4. And that's it. That's our answer. Okay. Again, we are just using this law of exponent and subtracting some fractions, and you get your answer. So this was our second last question. Now we have our final question. Okay, our last question. This is relatively very easy compared to all these questions we have done. Let's see what our final question looks like. So our final question was 7 to the power 1 over 2 and 8 to the power 1 over 2. To do this question, I just told you about a simple rule of exponent before. If you have something like x to the power a by y to the power a, you can write this as x by y to the power whole a. Similarly, if you had something like x to the power a times y to the power a, what you can do is you can write them as x dot y to the power whole a. Okay, so what we're going to do over here is we are going to use this second one. Here we have same powers for both these 7 and 8. Both of them have 1 over 2 as power. So what we can do is we can write it as 7 dot 8 to the power 1 over 2. We're using the second rule. And we know 7 times 8 is 56. To the power we have 1 over 2. And done. That's it, okay? We just multiply those two numbers, which is 56, and we have our 1 over 2 over here, and we just copy that. And done. So that's our final question. And it's, I think, the most easiest one till now. So if you watched till the end, thank you for being patient. And if you liked our video, please give us a thumbs up and subscribe to our channel for future maths videos. Bye-bye.